Hello, in this video we're going to look at some function notation and then some applications of that we will see a lot during class this semester. Alright, so we're going to use the function f of x equals 4x squared minus 20x plus 17. So function notation, what we're going to do, for the first example we have f of 4. What we're going to do with that 4 is we're going to take this 4 and plug it in everywhere we see an x in our function. So we'll have 4 times 4 squared minus 20 times 4 plus 17. And when we simplify that, we'll get 4 times 4 squared is going to be 64. Negative 20 times 4 is negative 80, plus 17. 64 minus 80 plus 17 is 1. So our function f of 4 equals 1. That does tell us a little bit about the graph of the equation. That means that when our x is equal to 4, the y value on the graph is going to be 1. So that means that the graph of this f of x is going to go through the point 4, 1. All right? And we're going to do the same thing no matter what's inside the parentheses. Our next example, we want to find f of a. With this same function, all that means is we're going to replace those x's with a's. And so we get 4a squared minus 20a plus 17. That one we can't simplify any, so that would be our answer. Doing the same thing for this next example, f of 2 over m, we're going to get 4 times 2 over m quantity squared minus 20 times 2 over m plus 17. So cleaning that up just a little bit, 2 over m, remember from our exponent rules, we can write that as 2 squared over m squared. So that's going to be 4 over m squared. And then we can think of this as 20 over 1. Fraction times a fraction, we multiply straight across. That's going to simplify to 40 over m plus 17. So 4 times 4 over m squared is 16 over m squared minus 40 over m plus 17. And you can either leave it like that or you can get a common denominator. Our common denominator here would be m squared, 1 and m squared. M squared is going to cover all of that, so it would be 16 minus 40. Here we would need to multiply by another m, so we would have an m on the top as well. And then here we would need to multiply by m squared on top and bottom, so we would get 17 m squared all over m would also be another form that you would see the answer in this. All right, this last one here, f of x plus h minus f of x all over h, this is what we call the difference quotient. And our approach is going to be exactly the same. We're still using that same function, but now we're going to plug it in 2 separate pieces. So if you want to, you can kind of go off to the side. F of x plus h, if we do it just like we did the previous one, we get 4 times x plus h squared minus 20 times x plus h plus 17. We need to go ahead and simplify this. Remember, order of operations, we cannot multiply this 4 until we square it. So we square this, we'll get x squared plus 2 times x times h plus h squared. We can distribute the 20. We'll get negative 20x minus 20h. We still have that plus 17. Now we can multiply by that 4. We get 4x squared plus 8xh plus 4h squared. And then the rest of it that we found in the previous step. And that would be as simple as we can get for f of x plus h. So now if we do f of x plus h minus f of x, we're going to take that polynomial that we found for our f of x plus h, and then we're going to subtract our f of x, that original function, 4x squared minus 20x plus 17. We do want to distribute the negative there. So we've got our f of x plus h. Distributing that negative, we're going to get a minus 4x squared plus 20x minus 17 on the end. And then combining like terms, we have 4x squared and a negative 4x squared that are going to add to 0. We've got a negative 20x and a positive 20x that's going to add to 0, and a positive 17 and a negative 17 that are going to add to 0. And that should always happen where everything that was in our f of x should cancel out with something else. So what we have left, f of x plus h minus f of x, is 8xh plus 4h squared minus 20h. Another thing that will always happen in these problems is you will always have an h in all of your terms that are left. So now we're ready to go back up and actually find what we're looking for here. So f of x plus h minus f of x all over h. I'm going to go ahead in this step, I'm going to go ahead and factor out that h. When we factor that out, we'll get h times 8x plus 4. I'm going to pull 1 out, but I'm going to still have an h left. And then 20 over h. What will happen is the same number of terms. Here we've got 3 terms. Inside the parentheses, you will still have 3 terms. Even if you only have one h on the end, when you factor it out, make sure that you keep 3 terms there. You would have a plus 1. Now we can divide h out of the top and the bottom here. And so our difference quotient for this function is equal to 8x plus 4h minus 20. And so that would be our difference quotient. You can split it up and work it the way I did here, or you can just jump right into it and plug in f of x plus h minus f of x all over h and jump right into it. All right, I'll see you guys next time.